So hello guys, my name is Kelvin Yadzayo. I'm gonna be teaching you blockchain today. This is blockchain for beginners. Okay. Uh, what is blockchain? In this case, blockchain, you can see from the definition that blockchain is a distributed, immutable digital ledger that records transaction across many computers, so that it involves record um, uh, cannot be altered retroactively without iteration of all the subsequent blocks. So this is blockchain in general. And let me just turn down the notch. So this is blockchain. You can see here the most important part about blockchain is this part, right, where it's immutable. When you say it's immutable, it means that it cannot be changed once it's done. This is blockchain in essence. So at first, when you do a blockchain, or let's say there's a lot that comes into play, which we're gonna talk. So basically, we say it's a chain of information, of blocks containing information distributed across computers. So we're saying the information is in pieces, then it's distributed across computers. Let me try to find color that is more this one. Yep. So this, yeah, right. Are you able to see? I don't think you can. So this, yeah, but I'll keep this. Let me try red. This red works. Yeah, it does work. So basically, blockchain is a shared, secure using cryptography, which means that it works perfectly. Right. Then it's immutable, which is this part, right? And you can see from this part that you initiate your transaction, it comes, this is your transaction, it's propagated into the network, then there are people who run what they call the nodes, which are decentralized computers. Then in this case, this decentralized computer is what's being used by people to validate your transaction. So this is the part where after the transaction have been validated, they are moved back into they are moved into the blockchain, which is this part, just this part. Let me try to find a very good annotator. So this is this part where the blocks are moved into the blockchain. Then after that, your transaction is completed and you get a notification, which is this one. So understand, this is the basics. Then we move on. How does the blockchain works, right? So how does the blockchain work? We have the blockchain process. We start with the transaction request, which is here. The transaction request, where people request you initiate a transaction, which is in this format, and then it is broadcasted into the transaction pool, which is what we call a pool, right? So let me try to walk you through this process from top to down. There are transaction. A transaction is requested and broadcast to a peer network, which is this part, right? Then the transaction is combined with other transaction and create a new block, which is this part. So when your transaction is here, and a miner. So this is what we call, this is the transaction pool, where we have a couple of transactions. So this is a pool of transaction, right? And then so these are other peers in the network who picks up what we call miners, who pick up your transaction, right? After your transaction is picked up, then it's mined, which is what we call verification, right? In this case, then once the verification is done, a transaction is broadcasted to the network as confirmed, right? Then there is the block creation, which is this part, where we are creating the next block, because these miners have confirmed that this is a valid transaction, right? And then they receive, the nodes receives rewards in form of crypto or whatever the case. Then the transaction is complete, the block is permanently added, and the transaction is complete. This is this part where you get a notification in your MetaMask that the transaction has been confirmed. We are back at this same place again. So this is the basics of blockchain. Then we move on to what is decentralization. So decentralization and distributed ledger technology. In this case, we're saying decentralized means no single entity can control the entire network. Instead, control is distributed among participants. So you remember where we have the pool of transactions. So we have a pool of transactions here, which you have sent. Let's say you want to send money. Your money is sent into the pool, transaction pool. Then there are validators, which are outside this. Then these validators listen to this pool, and to this pool, then they mine a transaction. Then once they perform what they call proof of work. After proof of work has been completed, the person or the node, which is one of these guys, if they manage to confirm one of the transaction, which is proof of work, by calculating the next hash, it's then confirmed into the transaction pool. In this case, so we're saying these are the part where we are called, these are distributed nodes, or a decentralized ledger. So with these one of the nodes, each of them carry a part of the same distribution ledger. And what they usually do, so this person is this node, or a person, or your computer, when you join the network, is a copy of the entire block, and also this guy is a copy of the entire block, this guy is entire block, and this guy is a copy of the ledger, which what we are calling the ledger. In this case, this also guy has the entire of this book ledger, right? And then when a new transaction is formed, one of these guys picks the transaction. It's written on, confirm the transaction, write it on the ledger, broadcast it to these guys, broadcast it to these guys. So this is what we call, in this case, we are saying that it's a fully connected network. Then so let's move on to the advantages, or the strengths and weaknesses of a distributed ledger versus the traditional system. Normally, this centralized system contains a single point of failure. You see this when banks are down, or if your bank is down, you can't make transaction to another bank, or the other bank can make a transaction to you. We often see this in our day-to-day lives. Then in decentral distributed ledger, we don't have a single point of failure. We have multiple points of control. So in essence, this network is it supports redundancy. Even if when one of two nodes are not available, the network can still function, as well as other nodes which are not available. So you can see here that this node are not connected, so they can still work. This is where the single point of control and single point of multiple points of control in this case. So we're saying each and individuals in this play part in the ledger, and then this part only the bank plays the part in the ledger. Then we have single point of failure, then no single point of failure. It's controlled by the authority, which is the government, the Reserve Bank, or the bank itself. They are the ones who make the police changes whatever happens to your money. Maintained by network consensus. This is a distributed ledger, so every node has an equal or participating right into the ledger. And faster but less secure. This is not always the case. I don't know how I reach here, but this is no longer the case these days. We have now layer 2, which is more faster than the traditional banking system, and it is also more secure. So here we can say this is now faster and more secure so, compared to the traditional system, right? Then so this is all about the distributed ledger. Then we have another concept. We move on to another concept called cryptography. In this concept, we are trying the way in which the blockchain is secured. Cryptography is a foundation of blockchain security, ensuring data integrity, authentication, and immutability. So the key concept that follows with these with cryptography and security is public. With hash functions, we have concepts such as hash functions. We have concepts such as public and private key pairs, and we have a digital signature. So I'm gonna explain this in a brief way, which is what are hash function. One way, this is more like an algorithm that offers one-way mathematical function that converts data of any size into a fixed strength length string. Even a tiny change in the input creates a different output. So in this case, we're saying a hash function is a algorithm that compresses any amount of text into a single or fixed size length. Let's say we have a 42 string length. Even if we are to put 200 character text, it always produce a string that is hashed to that 48 length string, which is as a result of a hash function. And any slight change into the input character will result into a different hash function. So in concept, we're saying we have words which are like I am a male, right? This is a string of characters, right? Then we have my name is Kelvin Nyatsayo, right? This is my name and surname. So we have a hash function here, which is a hash function. If we put this string into a hash function, which is this algorithm, it always produces, let's say, 1, 2, 3 A, right? if we put this text again into the same hash function, it always produce maybe 1, 2, 3, b. This is the fixed length. So you can see from a hash function that this is a fixed length, right? And also this is a fixed length. But if we go back to our input, right, this is not equal as this. And also one thing that you can take note of this is that the strings are different. So any slight change, or maybe introduce a comma here, might result into a C here. If we put maybe a full stop here, will result into here being maybe instead of A it will be Q. So this is not literally how, like, it's gonna be numbers, but it's a way to visualize the concept. So this is what usually a hash function works like. Then we have public and private keys, right? Users have two keys, which is the public, the one that is shared by everyone, and the private key, which is kept secret. The private key is it really signs transactions, and while others verify using the public key. So in essence, a public key, in this case we have a public key, then we have a private key. So it's more like they work, what do you call it, this is more like how can you identify yourself. So this is more like your public name. People, yeah, the best way to explain this concept is like your private key is more like your ID number, right? But then your public key is more like your name, right? So meaning to say your name and surname and age and all that is your public information, but usually your ID is usually kept secret to you, because your ID number is exposed, somebody can use it for different things. That's the same case with the private and public key of this type of scenario. So the public key is what you use to interact or to be identified on the blockchain with. So people know that it's you, and you with your private key, you can sign anything on the blockchain using your public key via your private key, because private key is how you identified your public key. So it's more like it's a one-way function where the private can produce the public, but public cannot produce the private. And then this is where you make your transaction and sign. That's the concept I've already explained. Now let's move on to the next. How do we move to the next? Okay, then we talk about consensus mechanism. Consensus mechanism, how blockchain reach an agreement. There is different types of consensus mechanism. The one that are the most popular are proof of stake and proof of work. This is if we go here, proof of work is associated with Bitcoin, and also Ethereum. So you remember those nodes that we used to have, right? And then this is transaction pool, this is nodes, this is nodes, this is nodes, this is nodes. So the way these nodes reach a consensus after verifying, or the way they verifies this is to the miners compete for to solve the complex mathematical puzzle. The first to solve it gets add a new block and receive reward, which is in form of a crypto that requires a significant computational power. Then we move on to proof of stake, where validators can select to create a new block based on how many coins they hold and are willing to stake as collateral. And this introduces a form of governance. It's a concept that we'll teach later on. Then also the stake part. If you stake, that means you can be penalized on your stake if you vote for wrong decisions. And then there's other mechanisms such as delegated proof of stake, where you can delegate to someone to let's say the network requires 32 ETH, and 32 ETH in this case is too much for you to get because of price of ETH. You can come together. This is what we call delegation, and delegate to an SPO who will let's say 3 people come up with this one will come up with 8 ETH, the other one 8 ETH, the other one 8 ETH. All together makes it 32 ETH, which is you delegate to this person, then they stake 32 ETH. Then it becomes a validator in this case. Then after this, we move on to cryptocurrency. What are cryptocurrency? Cryptocurrency are digital assets on a blockchain. Cryptocurrencies are digital or virtual currency that use cryptography to for security and operate on a blockchain technology, independent of central bank. The types of cryptocurrency: there's Bitcoin, which is the first well-known cryptocurrency. Then there's Ethereum, which can be used, which is available at the moment. We all know Ethereum. Then we have Bitcoin. Then we have stable coins, the one that mimics existing stable coins. Then utility tokens, the one that are used to run a network for a specific functionality. This is what we call utility tokens. Then there are security tokens, which serves a different aspect. And you can see from here that Bitcoin hold the largest market cap. In this case, it holds a lot of market cap in this case. Then uses of use cases for blockchain and beyond. In this case, they can be used in various factors. Blockchain application in various industries. Those include healthcare, secure medical records, drugs, traceability, clinical trial management, supply chain, product authentication and verification. You can use that for as blockchain. We can use it to vote, just like creating a transparent, a decentralized voting mechanism where each individual can vote on the decision of the blockchain. Then they can we can use smart contracts, self-executing contracts directly without the third parties. We can take legal contracts, convert them into code that is very static and cannot be changed. Whenever we enter into an agreement using this contract, it executes as it's supposed to, and everyone benefit from the smart contract without the third party, which is a lawyer in this case, whatnot. Then we can also use it to verify digital identities and so on. There are so many use cases for this. Then let's weigh the benefits and the advantages and the benefits. Blockchain usually comes with security because it is tamper proof and no one can change the contents of the blockchain, right? Then it's transparent so that anyone can just go and see what's is changed or what's going on the blockchain, as it is public for everyone to see. Then no single point of failure or control. We all know that. Immutability, which means everything is cannot be changed once confirmed. Uh, Disadvantages, this is what we talk about: proof of work, which is currently being used in Bitcoin. In this case, it uses so much computing power to find the next hash or to mine the next block. So as we mine more blocks and more blocks, it becomes difficult, or the hash function or the next block becomes very even harder mine to be mined. In this case, this also comes with energy consumption, as it is computationally expensive, right? We use GPUs. GPUs all take more power, right? Scalability issues. This was with the Bitcoin, but this problem has been solved in other blockchains and other layers of blockchains. Complexity. It is very difficult to understand to an ordinary person. Usually, people associate the blockchain with cryptocurrency, which has been used to scam people, and now it is even difficult to sell blockchain. Regulatory uncertainty, due to the fact that, or the nature that the blockchain doesn't, not everybody understand it, not every border also understand what is blockchain, and they are not always keen to participate into the use of blockchain, which makes it even difficult, because we're saying regular or existing regulatory framework cannot be applied to this new technology, as it is decentralized, which means that you cannot control a single entity in this case, which makes it difficult. So regulators are working on this and try to find new ways or clever ways of regularizing blockchain and make sure that everyone participates. Then conclusion or key takeaways. Projection of Bitcoin, so you can all see that it has grown in price since 2017, or say since 2008. Blockchain is a distributed immutable ledger, like we explained that. Cryptography, consensus mechanism, we have explained almost everything here, and it's self-explanatory. So if you've got any questions, you can always leave them down below, or you've got any topics that you want me to explore, I'll be happy to do so. Thank you, guys.